Now, our last topic in this chapter is loan amortization. So, what is loan amortization? Well, loan amortization means once you have a loan, every month or every year, you'll be paying off your loan. And by amortizing the loan, you are allowed to pay off not only just interest on loan, but also the principal or part of the principal of the loan over the years, so that you don't have to pay a huge lump sum payment when the loan is mature. So before the Great Depression in the 1930s, most of the loans on mortgages or the houses are not amortized, and they typically have a maturity of 7 years. So in the first 6 years, the borrower will only have to pay the interest every year. But at the end of the 7th year, when the loan is mature, the borrower will have to pay the lump sum payment of the principal of the loan. So when the Great Depression happens, a lot of people found it's very difficult to pay that off because that lump sum payment is relatively a bigger number than what they used to pay, because they used to pay only the interest. So this is creating a chance for financial engineering, and actually loan amortization is the first type of financial engineering. So by amortizing the loan, it allows the borrower to pay not just the interest on their regular payment, but also part of the principal. So gradually, they will be paying off the principal. That gives them a chance to avoid paying off a huge lump sum payment at the end of the loan's maturity. Nowadays, most of the mortgage loans and auto loans are amortized loans. So that means every paycheck you make to the bank, whoever you borrow from, will be paying off not just interest, but also part of the principal. Now, let's look at amortized loan first. So suppose we have a $1 million loan, and then we need to pay off that in 5 years, and then it's amortized, and every year the annual interest rate is 10% and is compounded on a yearly basis. And in reality, most of the loans, like mortgage loans, auto loans, they are monthly basis. And this is compounded on a yearly basis. It's kind of oversimplifying what we had as mortgage loan and the auto loans. But the idea, the process of amortizing the loan is the same. So first, we need to pay off this $1 million loans in 5 payments in 5 years. That means 5 payments because it's compounded on a yearly basis. Now, first, we need to find out every year how much we need to pay. Well, we will have to use the financial calculator in this case. So take out TIBA2 financial calculator. So type in 5 as the value for the maturity, or N, and then press the N key, and then 10%. And here, because we're using financial calculator, so you only need to type in 10, and then press the key I/Y. And then type in the present value, which is 1 million, and then press the PV key to assign the value to PV. And then because we need to pay that off, that means at the end, the balance needs to be 0, so 0 for future value. And then let's compute payment. Then this will give us every payment, how much is it? And then we have a few more steps, but let's save these for later because we need to come back to this later. Let's go back to the previous slide. So once you use the financial calculator to calculate the yearly payment, you should be able to get this number as the payment, $263,797.48. So every year you need to write a check and pay your lender this much, $263,797.48. And then out of this payment, out of this $263,797 48 cents. Some are payment toward the interest, and some are payment toward the principal. Now, how much is the interest payment and how much is the principal payment? Well, the lender typically sends you a bill and that they gave you a breakdown of that interest payment and the principal payment. But how did they get these numbers? Well, here let's see how they calculate these payments. So at the beginning of this loan, you owe $1 million, right? And the rule is you always have to pay off the interest first before you can pay off any principal. Now, 10% is the interest rate and it's compounded on a yearly basis. So the first year, how much interest do you owe to the lender if you borrowed $1 million to start with? Well, 10% times 1 million, that's going to give you $100,000. So that $100,000 is your first year's interest payment. And then you paid in total $263,797.48. So subtract the $100,000 of the interest payment, the rest $163,797.48 is your principal payment. So during the first year, you pay off $163,797.48. And then the beginning balance is $1 million, and you pay off $163,797.48. So $1 million, subtract this number, the rest is your ending balance, which is also the beginning balance of your second year. So the ending balance of your first year will be $636,202 and then 52 cents. So that's from 1 million minus 163,797.48. Now, during the second year, you start with a balance $836,202.58. So 10% is the interest rate, and multiply this beginning balance of the second year by 10% interest rate, you will get the interest payment that you need to pay. So that'll be $83,620.25. And then in the second year, you paid $263,797.48. So subtract the second year's interest payment, $83,620.25. From that, you will get the principal payment that you paid in the second year. And that'll be $180,177.23. And then the beginning balance of the second year is $836,202.52. And you paid off $180,177.23. So the remaining balance, or the beginning balance of the third year, will be the difference between these two. So 836,202.52 minus 180,177.23. And then the beginning balance of the third year will be $656,025.29. So following the same process, you will figure out the interest payment in the third year, and then the principal payment, and the remaining balance of the third year, and then everything for the fourth year, and then everything for the fifth year. So by the end of the fifth year, you should have a principal payment which is exactly the same as the beginning balance of the fifth year. So that leaves zero balance as the ending balance of this loan. And this is exactly what happened in our loan amortization. So in the fifth year, you should have a principal payment which is exactly the same as the beginning balance of the 5th year. And this is what we see in our loan amortization. So the ending balance of the 5th year is 0. Now, all these can be done by using the financial calculator. First of all, we will have to calculate the payment, which we just did in the financial calculator. So we will have to use the function keys to calculate the payments. Well, we did this by entering 5 for maturity, 10% for interest rate, 1 million for present value, 0 for future value, and then we compute payment. That's what we did early on. And then don't erase anything in the calculator and save that in the memory. Okay? So while we have these values stored in the memory, we can go ahead to calculate or to find any principal payment, interest payment, ending balance of any year. So how is this done? Well, look for the yellow second button on the financial calculator, press that, and then press the key amortize, A-M-O-R-T. And then on the screen, the calculator will be asking you what's the value for P1. P1 stands for the starting year. And then let's say we want to know the first year's principal payment, interest payment, and the ending balance, all that. So here we want to start at year 1. Enter 1 as the value for P1, and then don't forget to press the enter key. Okay. Once you enter 1 for P1, use the down arrow button to navigate and press that. You will see P2. So the calculator is asking you what's the value for P2. And if we are looking for the numbers in year 1 and only the numbers in year 1, then we should start at year 1 and also end it at year 1. So the value for P2, P2 stands for the ending year. That needs to be 1 as well. So enter 1 and then press the enter key to assign a value to P2. Now you can use the down arrow button to navigate and find out what's the principal payment, interest payment, and ending balance. So you only need to press the down arrow key and keep pressing it, you'll get all the values. Now look at another example. Let's say instead of looking for the numbers in year 1, I'm interested in finding out the principal payments, the interest payments, the ending balance in year 2. So what do you think the value for P1 and P2? Well, in this case, they both need to be 2. Again, yellow second, if you're still on that screen, amortize, enter 2 for P1. Don't forget to press the enter key. Down arrow, enter 2 for P2. Don't forget the enter key again, and then keep using down arrow key to navigate and find out the interest payment, principal payment, and ending balance. Now, some people might ask, what if I enter 1 as the value for P1 and 2 as the value for P2? Well, in this case, you can see what happens. So let's do this. The yellow second bottom, amortized, and then 1 for P1, 2 for P2, and use the down arrow key to navigate. You will see the interest payment is the sum of year 1's interest payment and the year 2's interest payment. You see the principal payment as the sum of year 1's principal payment and year 2's principal payment. And then you will see year 2's ending balance. So by giving the value 1 to P1, 2 for P2, you will get interest payment of the first 2 years, not just 1 year. And then you will get the principal payment as the sum of the first 2 years instead of just 1 year. So this is how you use the financial calculator to replicate the amortization table as was shown on the previous slide. So in this chapter, we covered the time value of money. And then these are the major topics that we went over. So we talk about the future values, present values, how to calculate them, by using the generalized formula and the financial calculator and the Excel spreadsheet. We talk about the annuities, the major types of annuity, ordinary annuity, annuity due. Timing is the major difference. Ordinary annuity, all the payments happen at the end of the time period. Annuity due, all the payments happen at the beginning of the time period. And that's the major difference. And then we calculate the future values based on the financial calculator and the Excel spreadsheet. And then we look at the calculation of uneven cash flows. So what if the payments are not fixed? Then you can't calculate them as annuity. It has to be done as an uneven cash flow. And then we look at the compounding frequency. What difference does it make? So how to convert the nominal interest rate to effective annual interest rate. And then the last topic we'll cover in this chapter is how to amortize a loan. How to use a financial calculator to get any number in the amortization table. So these are the topics we cover in this chapter. Thank you.